So let's go ahead and do a little bit of a recap of what we've learned so far about sample variance and sample standard deviation. Variance for us is the difference between any particular data value that we're measuring and what we expect that value to be as an average. And so our example was heights of students in the high school. And so what we decided to do was make believe that we had done some data and that we had some numbers. And we said, okay, let's pretend we have the average height of all the students in the high school was 5'6". And then we looked at a small group of those, and we had student 1, 2, 3, 4, 5, and 6. Some of the students are taller than the average, and some are below the average. Student 1 is 5'5", and student 2 is 5'1", 5 inches below. And student 3 is 10 inches above, student 4 is 3 inches above, student 5 is 8 inches above, and student 6 is 3 inches above. Now what I've done this time is I've added some things. See this? X sub 1, X sub 2, and down here X sub 6. The subscripts signify that each of these is an individual data element in our overall sample. So we're not using lots of different variable letters, we're just using X, and then we signify the difference by saying X sub 1, X sub 2. So here's that visual example of the difference, and here's a below, here's another one below. There are 4 that are above the average. And then what we want is to be able to line them all up as positive numbers so that we can get an average of the average difference. And when we're talking about the average of the average difference, we're talking about variance. And we're talking about a sample variance. All right, so key concepts for variance and standard deviation. X is just the variable representing one data value, X bar. And X bar is really just the mean for the sample data values. We call it X bar because it shows anyone else who's looking at our data that we're looking at a sample and not at the entire population. So in this case, we'd be looking at a sample of high school students, but not the entire population of all 100 high school students. And when we got that average, we'd call it X bar, the sample average. And you could have more than one sample, so you'd have different X bars. And then here's an example of X1 minus X bar, and all that means is it's a specific one of the samples. And I had written -1 right there because I was using X number 1, and X number 1 was right here, just 1 inch below the average. X minus X bar is the difference between any one data value and the average or the mean. I've got some parentheses and I have X minus X bar, and then what's happening to that data? We're squaring it, right? This is X minus X bar squared. And we do that to eliminate the negative values in our differences, because some of them are below average, some are above average. That's sigma, and then here we put the sigma, or add them all up, next to X minus X bar quantity squared. So there would be a little number here, right, signifying that we're doing X sub 1, X sub 2, X sub 3, and all of them, right? That's how we would know. But just generally, when we put the symbol together, we're just saying X minus X bar quantity squared. Put the sigma in front means add them all up. So doing this way gives you 34.7, but what we really want to do is do it by n minus 1. So here we got the 34.7, took the square root of 34.7, and we got 5.89 inches. If we take the same thing and divide by 5, we get 41.6. Take the square root of that, we get 6.45. That's a little bit larger. So what we have now is a specific symbol, S squared, that's equal to this formula right here, which is just the sum of squares divided by one less than the number of numbers that we have. And instead of calling it an average, it's no longer just an average. It's known as the sample variance because it's a collection of the differences that we put together. We add them all up and we square them and then divide by one less than the number of numbers, and we get what's called the sample variance. But all our numbers have been squared, and if we're talking about inches, we're talking about squared inches here. Squared inches, it's not practical to talk about squared inches when you're trying to talk about height, right? Squared inches are for area. We want to talk about height. So we need to take the square root of this. And if we take the square root of both of these, the square root of s squared is just s, and the square root of this has a square root symbol over it now. So when we do that, we're changing the sample variance into something that we call the sample standard deviation. It's how far does our data say we deviate on average from the mean or from the average. The standard deviation. And a standard deviation fits into a standard normal distribution curve. All right, this is a little muddy, but it's got the main ideas right here. So let's take a look at this. There are specific things that happen when we're talking about a standard deviation. So right here, at this point, and on this side also, this line here and this line here, they are one standard deviation from the mean. And the mean is in the middle here. There's our average, there's the mean. Going one standard deviation up, we end up here. Going one standard deviation down, we end up here. Now I know these numbers are hard to read, but that's supposed to say 34%. And this is 34%. 34% of what? 34% of your sample. And when you put it under this distribution curve, you can start to estimate about your population. You take a sample, you get some estimates, you run through the math that we were talking about just a second ago, right? We go through this and we do it with our different data elements. We have our X bar. We go through each of these different data samples. Go X minus X bar, square it, add them all up, divide by the number of numbers minus 1. We get a variance. Take the square root of that, and we get a standard deviation. We're going to get some kind of number. What it means is, for our case, this spot here, the mean is at 5 feet 6 inches. Okay? This is one standard deviation up. That's plus, what do we say, 6.5 inches, 6.5 inches? And this over here is minus 6.5 inches. What's 5 foot 6 plus 6.5 inches? 5 foot 6 plus 6 inches gets you to 6 feet and then a half inch. So this right here would be 6 feet 1/2 inch. Right? What's 5 foot 6 minus 6.5 inches? That's 4 feet 11.5 inches. And that's this point right here. So if we had an average height in our school for students in the high school of 5 foot 6, and we did our calculations with a good sample, we would come up with a standard deviation of 6.5 inches. Okay? So plus 6.5 inches means we would get up to 6 foot 1/2 inch. Minus 6.5 inches means we'd get to just under 5 feet. And what would that means is that 34% of our population fits in here. 34% of our population fits here. That's 68% of our population. Okay, that wraps up our lesson for right now. In our next video, we'll look at the standard normal distribution curve and apply the idea of standard deviations and use our own student height data. See you then.